Hello guys, welcome to my YouTube channel. In this video I'm gonna show you how to simplify conversion of a region under for certain mapping function. Okay, let's move on. Okay, for the first type of mapping, consider W equals AZ plus B. When we write it in the Euler form, we have got W equals absolute of A times R e to the I times theta plus argument of A plus real of B plus imaginary of B. If we wanna have a explanation here, this has got a expansion or shrinkage of a region, at the points of region. This will work on rotation of the points, and this will change up or down and horizontal or vertical movement, horizontal or vertical movement. Okay, to be clear out this formula, I want to tell you 3 examples. Okay, I have brought you 3 examples. As an example of one, we have pi z. Pi z, remember of me, like we can matter with A as pi. It will have an expansion or shrinkage. As it is bigger than 1, we will have an expansion of pi of the points of the region as much as pi, as much as pi. For the second one, I have brought 1 plus I times z. We open up this complex number. It's better to memorize this. It is if you wanna write down in Euler form, root 2 of e to the pi over 4i, this times z. Okay, we will have an expansion as much as root 2 of 2 root of 2, and a rotation as much as pi over 4 in triangular direction or in counterclockwise. Okay, and the third one, we have 1 over 2z plus 3. We will have a shrinkage because it is lower than 1. We will have a shrinkage or traction as much as 1 over 2 or half, and a movement to as much as 3 units to the right because it is positive. And if we draw the polar coordinate, this is real axis and this is imaginary. Okay, we have it is, if it was 3i, it will move up, but when it is 3 with nothing else. Okay, for the second type of mapping that I chosen for this video, it's W equals 1 over z. We can write this down as W equals z to the power of -1. If we write down in the Euler form, we suppose rho and phi for this new region. We have e to the oh, rho e to the I phi. We will have r e to the I minus theta, or please wait, it is 1 over r, 1 over r more e to the I minus theta. Okay, then we will have, then as an conclusion, rho is equal 1 over r and phi is equal minus theta. It shows that distance between points and center are becoming vice versa, and angle between points and positive side of real axis becomes minus 1 times. You simply multiply by 1. This is how to clarify. Okay, in order to understand this clearly, I brought you an example. Consider a hypothetical point A which has a distance of 2 and angle of p over 4. Under 1 over z mapping will become what? It's a question for us. Okay, if we want to use our conclusion, we simply write rho equals 1 over 2 and phi equals minus pi over 4, and this is how it goes. Rho of 1 over 2, it is somewhere like this. If we consider this 2, this is 1 over 2. If we wanna see where does a point of this region, this orange region, will go, 1 over 2 and angle of 1 pi over 4 minus pi over 4 will be somewhere like this. Apron we call it, and this point we call it B. We'll have an distance of 1 over third. This is E here, and okay, oh, I made a mistake. If we consider this point, pi over 6, pi over 6, and it will simply sends out the region 1 over 3, sends out the inner point to the outer one. Okay, for the third type of this mapping function, chosen w equals 1 z to the power of n, which is n is a natural number and it's not equal to 1. Okay, we simply write it down in the Euler form. Everything that is exponentiated, we write it down in Euler form. If we write down this in Euler form, we will have rho e to the I phi equals r times n r to the n and e to the n I n theta. Okay, we will have a conclusion here also. Rho equals r to the n and phi is n theta. It has shown that the distance between points and center of the coordinate becomes exponentiated by n, and the angle between points and positive side of real axis becomes n times multiplied by n. Okay, as an example of this mapping, I have drawn this 1/4 of circle. We wanna find out what it will become under this special mapping. Okay, the radius is 3. Rho becomes 3 to the power of 3, 27, and comes n theta 3 times p to the 2, pi over 2, sorry, and become 3 pi over 2, or 270 degrees. 270 degrees in a triangular direction. We will have this region, bigger radius and bigger space. It is 27, and this is 3 pi over 2. This is our new region. New region will look like this. Okay, for the fourth one, we will talk about W equals root n root of z in the Euler form, like the rest of the example that I talked about. It's rho e to the I phi root of r e to the I theta. We can write this down in the exponential form, r over r to the 1 over n e to the I theta over n. As a conclusion, rho equals root of nth root of r, and phi equals theta over n. This is how we write down our conclusion and use in our example. Okay, as an example, consider this region. It doesn't have any ending. It is to the infinity. And okay, this rho r of this region is infinity. Then rho becomes n root of infinity. It's infinity, and theta of this region is it's pi, phi becomes pi over n, as n is 2, pi over 2. Okay, we will draw this region. Theta of pi over 2 is become the first region of the coordination, and it has also a row of infinity. I forgot to write down this. If you remember, n must not be equal to 1, and it's an element of natural numbers. And another tip that you should consider is theta that is limited to this region, or you can have, and theta is limited to this region, or minus pi and pi. Its length actually is 2 pi, and this is 2 pi also. If you like this video, feel free to subscribe to my channel. Just click on the subscribe button below this video. If you want exclusive content about engineering mathematics that I only share with my followers and subscribers, visit makeunion.com and subscribe to newsletter.